Herewith I will show you that my structured model paper number 5, full detailed solutions, pure mathematics. So I hope you complete before me all the 10 problems. Those are newcomers, you can view that in the channel. You can see the paper is uploaded already, that 5th model paper. Okay, this first question as usual problem in the pure maths paper, structure type, using the mathematical induction. Using the mathematical induction, prove that for every integer value, positive integer n, show this. It's my 3rd pure maths paper. I worked already 2 pure maths structured type and 2 applied completed. So the previous 2 pure maths I shown how to work this induction method. This is my 3rd problem therefore. Okay, what the idea, first place, show first point, if n equal 1. If n equal 1, show this is true. Okay, so left hand side, LHS. Left hand side, sigma r into 2 to the power r minus 1, r equal 1 to 1. That means one number, that 1 to 1 means 1 to 1 and for 1. So what is value? R is 1, therefore 2 to the power 1 minus 1. That is 0, power 0, 1, therefore totally 1. Left hand side, answer is 1. See right hand side, RHS. RHS right hand side, put n for 1. 1 plus 1 minus 1, 2 to the power 1. 1 minus 1 is 0. 0 into anything 0. Here 1. Okay. Yeah, we can say therefore LHS equal to right hand side. That means what? The given statement true for n equal 1. Next, assume that given that statement or formula is true for what? N equal p. Assume that true for n equal p. Assume that true for n equal p. This is the copywriting. That is right, show that is sigma r into 2 to the power r minus 1, r equal 1 to p, put n for p, equal 1 plus the answer side, show n for p, 2 to the power p. Okay, let's try copywriting n for p assumption. Now the last part, show what happened n equal p plus 1. If n equal p plus 1, next last point, if n equal p plus 1, that means we are adding up to summation what p plus 1 terms, from first term to second term, third term, fourth term, nth term and the n plus 1 or p plus 1's term. So that sigma r 2r minus 1 r equal 1 to n for p plus 1. Okay, if it's for example 50 term adding from 1, I can say I add up to 49 term and add the 50th term extra additionally. If it's sum of 100 term from 1, 2, 3, 4 up to 100 term addition, and the method, add up to 99 terms and added the 100th term separately. So can I write this form? Sigma r into 2 power r minus 1, r equal 1 to p. Add up to p terms and add separately p plus 1's term. That is, we call like this u p plus 1's term, p plus 1. Now we apply this, this is the assumption, wherever we use the n equal p plus 1, that simplification, we take the help of the n equal p assumption. This is sigma r1 to p is, here is the answer, okay, 1 plus p minus 1 into 2 to the power p. Okay, and what is p plus 1's term? What is p plus 1's term is what? If you want first term, put r for 1. Second term, put r for 2. 100th term, put r for 100. P plus 1's term means put r for p plus 1. So here addition, p plus 1, put r for p plus 1 into what? 2 to the power p plus 1 minus 1. That's all. Now you have to simplify and show what the actual answer you have to show now. In this expression, put n for p plus 1, what happened? 1 plus n for p plus 1 minus 1, 2 to the power p plus 1. This you have to show. To simplify and show that answer here. That's the idea. Therefore, here 1 plus p minus 1 into 2 to the power p, okay, plus p plus 1, 2 to the power p, plus 1 minus 1 cancel, p, right? Hereafter 1 plus, can I take the 2 to the power p out? 2 to the power p out, what happened? Here p minus 1 plus p plus 1, is it? Okay, so therefore 1 plus 2 to the power p, here minus 1 plus 1 cancel, p, 2p, p plus p, 2p, right? So I show here 1 plus, here 2, you can simplify this here. This is 2p, here 2 to the power p plus 1. If I take the, what simplifies it, that answer is there. p, 2p minus 1 plus 1 cancel. 2 to the power p. Here 2, here you see these two bases are same, therefore sum the power. 2 to the power p plus 1 into another p. Actually this is the answer, see there 1 available. Plus 1 minus 1 cancel, p available, remaining is there. Now better you show what the original problem, if you put n for p plus 1, what is the expression? That part you have to rearrange here. That is 1 plus p plus 1 minus 1, 2 to the power p plus 1. Okay, the bar also in the bracket form. Therefore, the original problem, what the value or expression if you substitute n for p plus 1, these things are available. Therefore, it's true, which is true for n equal 1, it's true for n equal p plus 1. There we write the sentence below. Therefore, the given statement is true for every positive integer n. Okay, that's the question. I hope you complete this simple every induction. Usually first problems are easy in any exam, chemistry, physics, MCQ, whatever. First problems are a little bit easy. The same idea in the all past exam papers, pure maths, induction become a easy question. You can answer within short time duration also. Okay, second question. That is the usual type, what we call the inequality using the graphical method. Draw the graphs of the functions. First one is what? Y equal modulus x minus mod of x minus 1. Okay, first I explain how to draw that graph. You know what the basically modulus mean, positive value. If it comes minus, we have to make as positive. There are some rules of mod x equal to x. If x greater or equal 1. Okay, otherwise mod x equal to what? Minus x when inside negative. If x less than 1. This we are using for every modulus type, right? Okay. So to draw these things, what the boundaries of the x value? Here 0 is the only extent. Here what? 1. So to complete the first graph, there are 3 boundaries of x. Less than 0, what happened? Between 0 and 1, how? More than 1, how? Okay. So see that if x less than 0, x less than negative side, right? Negative side, then what happened? Y equal, this is minus. In this condition, x negative, then you write another minus, put another minus and write what inside the modulus symbol? Minus x. Okay. And minus x less than 0. For example, put x4 minus 1. Put x4 minus 1. x4 minus 1. Minus 1 minus 1 minus 2. Or put x4 5 minus 5. Put x4 minus 5. Minus 5 minus 1 minus 6. It becomes negative answer. Therefore, we write another negative and show what is there. Okay, that. So y equal minus x minus minus plus x plus 1. So if you work check will you what happened? Y equal 1. Is it okay? Y equal plus minus 1 minus 1 plus y equal minus 1. If the x less than 0, the graph portion is y equal minus 1 form. Next one, more than 0, this region. If x greater or equal, right? For greater symbol, you put a equal also. But less than 1, right? Important, but less than 1. But less than 1 between this. So what happened? Y equal, here, this is what? Between 0 and 1 positive part. For example, half or quarter is positive part, right? Plus therefore x. Minus, here what? For example, put x for half. Put x for half. Half minus 1 minus half. Or put between this number quarter. X for quarter is minus. Inside the modulus is minus. Then, but the rule says, definition says, you show an additional minus and write what inside the mod symbol. Okay, that. So what happened? Y equal x minus minus plus x minus 1. That is it 2x minus 1? Is the graph portion between the 0 and 1. Y equal 2x minus 1, right? Okay. Next, see here. More than 1 equal also. If x greater or equal 1. X greater or equal 1. So what is y equal? Here positive, more than one number positive, therefore as it is x. Here what? Put x for 5, x for 2, x for 3, more than one value, positive, right? X minus 1. Therefore y equal, what happened? X cancel 1, y equal 1. Okay. So there are 1, 2, 3 shapes. 3 shapes to draw the first modulus equation y equal mod x minus x minus 1. To draw this, there are 3 shapes, three straight lines. To draw this part, when drawing a graph, we can find where the, in this case they ask a rough diagram, but important intersection axis points are important, where the graph cut the x-axis, y-axis, and each other cuts where coordinates. So you know the simple primary class order graph y equal mx plus c. If x is 0, if x is 0, y equal what? Minus 1. Okay. If y is 0, if y equals 0, x equal half. To draw this graph, that collection of data to plot pair of points. Okay, the same method we complete the other graph, other modulus equation. That is what y equal. So here y equal x minus 2 modulus minus mod x. So in this problem, those are now you missed to learn this lesson in the class, our theory class, or if you forgot everything, final chance to learn, those are preparing for exams. Clearly the explanation how to draw the modulus parts graphs. So we draw that one. Here what the boundary, what are the boundaries? Mod x only, therefore 0. Here x minus 2 mean 2. Between 0 and 2 we verify the values of signs. So here 0, here 2. So like here 1, 2, 3 portion, here all the same. Take here if x less than 0, that means a negative value. We'll see what happened to the graph. So y equal, this is less than 0, for example, minus 5. Put x for minus 5, that is minus. Other one also minus. Then what happened? You write an additional negative symbol and show as it is. Okay, the other also minus, then put another additional minus and write x. Okay, that. So what happened? Y equal minus x plus 2. Here minus minus plus x. So y equal to, so primary straight line, y equal to the parallel to the x-axis, y equal to. Next we see the between 0 and 2 the graph. So if x greater, what you call more than 0 or equal to 0 but less than 2, but x less than 2, right? But x less than 2 a value. So you can think x for 1, put x for 1 and see. This is negative but that is positive. This is negative, that is positive, right? Therefore y equal, this is negative, so put a negative and write it. But that is positive, therefore same, no any change. If positive comes, you can write so as it is. If minus comes only, you put extra minus and write the given expression. So simplify what happened, y equal minus 2x plus 2. So straight line, y equal mx plus c graph, y equal mx plus c. So she show how to draw these some points where the graph cut the y and x axis. If x is 0, if x is 0, what is y equal to? And if y is 0, if y equals 0, x is 1. Okay, x is 1 to draw that graph. And the final range, that side, last one, greater or equal to. Next one, if x greater or equal to, right? Greater or, both are positive, is it? Both are positive, right? So what happened there? For y equal, show as it is positive, no change in the modulus. So y equal minus 2, okay? Therefore 1, 2, 3 portions in the both location, the graphs. Now we prepare, roughly you prepare a coordinate axis and plot this. X-axis, y-axis, origin. The boundary value we need 0 to 1, 0 to 2. So if I mark here 1, here 2. Okay, no minus side, right? All positive that side. If I mark somewhere. So minus 1, minus 2 like that. And you have some y equal 1 there, y equal minus 1, y equal that values. Y equal 2 here, 1, here 2, here minus 1, minus 2, right? I complete this part now. First draw those graphs. X less than 0, x less than 0, y equal minus 1. How the graph? X less than 0, y equal minus 1. It's the graph. Y equal minus 1 graph. Less than 0. Okay. Next. Here, no? X greater or equal 0 but less than 1. Between this, see check. Between this, how the graph? Y equal 2x minus 1 shape. Y equal 2x minus 1. That means x0, y minus 1. x0, y minus 1. y0, x is half. Okay, x is half, right? X is half. We have the graph, but should be between 0 and 1, right? Between 0 and 1, it's a straight line like this. Is it? It's a straight line. So it becomes somewhere here. You can draw properly in the linear graph more like this. Check that is the graph. It becomes 1 also. If x is 1, y check 1. If x is 1, y also 1. No? If x is 1, y is 1. That's the answer between 0 and 1. So what happened the other one? Here x greater or equal 1, y is 1. If you don't check this, the 3 parts. One is y equal minus 1, y equal 2x minus 1, and y equal 1. The first occasion I complete the graph, right? Okay, now see this graph. This graph, draw that part. X less than 0, x less than 0, that is y equal to, y equal to what this one? Y equal to, right? Y equal to, and more than 0 but less than 2, less than 2. Between 0 and 2, check between 0 and 2, negative gradient graph. x0, y2 this, right? x0, y2 here. y0, x1, y0, x1 here. Therefore the graph comes like this. I hope you complete the check will you have one. If x is 2 minus, right, it becomes somewhere minus 2 also. If x is 2, y is minus 2, check that also. If x is 2, y is minus 2, right? And at last, x greater or equal to, yes. This is the graph. Okay, this is the graph. This is the graph here. So now the solving hereafter calculation part. There are two portions of graph both occasion. One I take y1, I take other one is y2 to explain is easy. Therefore, first I draw this one. I say y is y2 graph, y2. This is y2 graph. Here also the y2 graph. This is a y2 shape, y2 graph. This I say y1. This is y1 graph, right? And here this green color y1 graph, y1. That is, though you don't show in the exam paper answer script. I'm explaining any doubts. You can see how I'm showing this idea. Okay, next item, you find where the graphs are cuts are, this coordinate needed. That is very important, every modular shape. After that we find where the both cuts. See this coordinate, how to solve this coordinate, where these two graphs are cuts. Where these two graphs are cut, that means if I say this one, number 1 equation, number 1 here, other one is here, this one. I say number 2, solve the two graphs. There's no y1, y2. So solve these two graphs. You can find the x coordinate. I put this is 1, there 2, right? So what is 1, 2? 1, 2. You can equate the both. Both are y equal. Equate the both. That is 2x minus 1 equal minus 2x plus 2. So 4x equal to 3, therefore x equal 3 over 4, right? X equal 3 over 4. This part 3 over 4. We need the x boundaries usually as the range of the x. Okay. Now I got the problem. What the question is now? The problem is, problem, first they asked to draw a modulus graph. Using that equation, they will give an inequality. See what the question is. 2 into mod x plus 1 greater or equal x minus 1 mod plus mod x. Is the graph we have to solve, right? We have to solve this part. Okay. So, but the first graph you drawn mod x available x minus 1. Wow, what is that x minus 1 modulus? Not here there. Here x minus second graph x minus 2. Here no x minus 2. Therefore question is wrong or misprinted. So we think so like that. See the graph, it's okay, something there, this mod x available, x minus 1, something available there. And there are still is x plus 1. Therefore problem, the huge problem is how to work, how to solve this inequality using this graph. It's like a new question. Yeah, maybe like that. But we can do that. See, the idea is actually x minus 2 not available here. Also the both occasion modulus x available. See, here also mod x, there also mod x. Here only once mod x, another mod x needed. Therefore, see if I show like this, I take a new substitute form, right? New method. Can I take that? I make this modulus x because we have 2 times mod x here. 2 times mod x available. Therefore, I write a new term. I want to make this mod x. How, when it's become mod x? Or is x naught? X equal x naught minus 1 like that. Or better, otherwise I can say x naught equal to x minus 1. If I show that is x equal, for this x we apply x, now check that, for this x we apply substitute x naught minus 1. So x naught is a new parameter, but that is x, let it become x. There is no x naught, y naught x is, there is no y1, y2 graph. All xy plane, xy the values, xy are the values. So I say x4 x naught minus 1, because the idea is in the modulus, the actual problem, see there is a mod x, here also mod x. Also especially x minus 2 modulus available. But in the given inequality, there is no x minus 2. Then you check if you apply anything to x in terms of any other form, we can get the x minus 2 or mod x 2 times. That's why I took x4 x naught minus 1. Right value and see x4 x minus 1, see what happened. 2 x4 x naught minus 1 plus 1. Okay, greater or equal x4 what, x naught minus 1. Okay, and the other side plus what, x4 what, x naught minus 1 modulus. Remember there is no x naught, that is x later, right? So what happened, 2 into, this is x naught greater or equal x naught minus 2 plus x naught minus 1. Now see, is it okay? Can you rearrange what they given original equations? 2 x naughts available for the both of the equation given initially, and there's x minus 2. Therefore here what is 2 x naught means x naught plus x naught. Take 1 x naught that side, keep 1 here, and take the code in the problem, we rearrange. Okay, so here x naught modulus, can I take that one here, minus x naught minus 1. It's a good problem, good work. So I hope you can draw this. Sometimes it's confused. We think the problem is wrong, or I made a mistake in preparing the question. No, it's okay, correct. So here what are x naught minus 2 minus x naught modulus. Is it, check that? I am rearranging. Now see, this is what LHS, left hand side, that is right hand side. So only different x naught, but there is no x naught. You imagine that is x, imagine that is x. Therefore, this graph I took as y2, I took as a y2, my green color. This initially I drawn this y2, this y2. This is y1, check there, y1, right? So I want to find what are the x values or x value which takes y2 greater than y1. That means one graph is higher than the below, other one is below. One is higher. Which one? Y2. That means this drawn in black color. This y2 graph above, green color lower than that. Here see this part, y1 up, y2 down. No, I need the y2 up. You can't take this one. See this part, y2 up, y1 down. This can be taken. y2 up greater. This can be used. See this part here, in this case what happened? This is y1, here y2. You can't take. Yeah, I hope you can take this portion, is it? Check value, that is up, this is down. So what the x boundary? More than 3 over 4. X naught, not x, very important. X naught, you imagine that is the x naught axis. This is y or y naught. Okay, therefore x naught more than 3 over 4. X naught more than or equal to 3 over 4 is the solution for my substitute x naught. But the question is find the x boundary. Therefore come my substitute. I took this x naught is x plus 1 or x equal x naught minus 1. Therefore can I write for x naught x plus 1. X plus 1 greater or equal 3 over 4. So take the plus 1 other side, you can get the answer or solution. Take the one that side, x greater or equal 3 over 4 minus 1. That is a minus 1 over 4. Very important question. Practice this, keep in touch. Everything traditional part, the final part only something different. For this value, minus comma here. Somewhere minus quarter only the given equation valid or given inequality valid. Okay, see question number 3. Third question, solving a logarithm idea. So if x equal 6 plus logarithm basis 3 over 2 and 1 over 3 root 2 and so many the same square root extended to infinity like that. 4 minus 1 over 3 root 2. Again square root 4 minus 1 over 3 root 2. So new viewers, you can see the YouTube channel. I published this structured model paper. Okay, it's continuous like this. 4 minus 3 over root 2. Let's continue. The questions they are without using logarithm table. Without using logarithm table, show x equal 4. Sometimes you work this, otherwise confused, problem troubled you. Check how I'm explaining this. So if you mark x equal this 4, right? So it is difficult task to solve your logarithm ordinary method. If they are say use without using log table, so I hope using log table also you can find that answer. Difficult. Okay, see the method. See, this is continuous. There are 4 minus 1 over 3 root 2, 4 minus 1 over 3 2, and so on. Therefore, I take this part. This continuous part I take is y, right? That is I take as y. Okay, that part I take as y. So you write that let y equal with the square root, right? With the square root 4 minus 1 over 3 root 2 and a square root 4 minus 1 over 3 root 2 Again the square root 4 minus 1 over 3 root 2 and so on, right? So what the main method in this question, you have to remove the square root. Square root is a problem. Remove the square root. What happened to remove a square root? We square both sides. The y is that, what is y square? Therefore, y square is what? What happened if you square it? This square root is cancelled. That will eliminate, vanishes. The biggest square root only removed out, right? That is 4 minus 1 over 3 root 2 square root 4 minus 1 over 3 root 2 4. Properly see that, some of you misuse, you can't get the answer. See this clearly what happened, the biggest square root only removed. Inside other parts available, other square roots are available. Okay. So what is y square equal 4 minus 1 over 3 root 2. So here how many times this dot extend to many? Infinity, right? Infinity, billion times the roots extends. Therefore, see this is what? Again y. Only was one square root removed, the biggest square root removed. That means you know 100 minus 199. What is infinity minus 1? That also infinity. So only one root removed out, vanishes. So remaining also same, there's nothing. Therefore I say this is y, is it? This part is y, this part is again y. It's the same, I took as y. That's the tricky, try to understand this is y. And now rearrange a quadratic equation, rearrange a quadratic pattern. You can find the y answer first, then we can go to the x answer. So can I multiply this by square LCM? 3 root 2 y square, okay, plus y, is it minus 12 root 2? Check, will you that? Okay, equal to 0. Is it okay? Check that y quadratic equation in terms of y, that is 3 root 2 y square and plus y minus that. This is an irrational part, you can't take simple factorization. Can, but better you use the formula. X equal minus b plus so much, that's better. Use the formula. So y equal, therefore y equal minus b plus or minus square root b square minus 4 times a into c. A, okay, into c. C is a negative part, no? Therefore it becomes plus, right? Over 2 times a, okay, this is y, right? You know logarithm parts always positive. I do this is as y, it should be a positive number, plus the square root also, but logarithm, every square root plus or minus, but logarithm, there is no logarithm negative value. That is, you can't ever, you won't ever, you can't take that, we avoid that negative. Okay, therefore actually you don't need the negative symbol, plus is enough, right? Now simplify this, y equal minus, I say plus only, right? Square root, what is 36, 144, 289, check will you? 289 over 6 root 2, is it? Over 6 root 2. 289, 17, right? So y equal minus 1 plus 17 over 6 root 2. Y is positive where y greater than 0. That's why you can't take the negative symbol for y, right? So that's the minus 1 plus 17 over 6 root 2. Anything, is it okay that? Check, will you check that? So the answer y equal 16 over 6 root 2. Otherwise, what divided by 2? 8 over 3 root 2. Okay. So main part of the answer completed. But the question is find the x value. Now go to our initial problem. Go there. Therefore, what is that? Important question can be asked. Logarithm, it last 2004 they asked essay one logarithm, year after none. So many term papers, department model we have logarithm. It's grade 12 lesson, right? Grade 12 chapter is logarithm. Okay, now come to therefore. Therefore, x equal 6 plus logarithm 3 base is 3 over 2. Here 1 over 3 root 2 into what? Y. So y is 8 over 3 root 2. 8 over 3 root 2. Okay. Okay, that. So simplify that form. You'll show the answer is that 4. Answer becomes 4, right? Think any model of solving 6 plus logarithm base 3 over 2. You also have the root 2 is 4. 2 no root 2 is 2. Is it root 2 multiple is 2? 8 4. 4 over 3 square. Okay, 4 over 3 square is it? Is it okay? 4. Can I write there for this 4? Can I say 2 square? Can I write this like this? 2 over 3 all things square. Check that. Is it okay? 2 over 3 all things square. But if you know very clear some basic identities of rules of logarithm. What is the base? The same comes here. Power is the answer. This both comes same. Power is the answer. Therefore, x equal 6 plus logarithm base 3 over 2. Make this also 3 over 2. Negative index 3 over 2, but not square. Minus 2, is it? So I think all your work, all your maths. Therefore, x equals 6 plus. This both come same. Power is the answer. Logarithm property minus 2. See, nice problem, nice work. X equal 4. Long work, but if once you work hereafter simple, you can answer any type of question, similar question. The unknown is long expression. We take y, so build up for y first and come to the x. Okay, see next question, limit problem. They said using the sine 2 theta expansion for sine theta. Prove that. Answer also given their limit. N tends to infinity. N tends to infinity. Cos theta by 2. Cos theta by 2 into cos theta by 4, like a 2 square here by 4, and cos theta by 8 into cos theta over 2 to the power n. The answer sin theta over theta. Just remember in this question theta acts as a constant. Theta act as a constant because n tends to infinity. The problem we apply to limit approach to the n, not for theta. That's why answer is that. You can't say sin theta over theta is 1. That is when theta approach to 0. Here n tends to infinity. Okay, to they say the idea using the double angle sin 2 theta pattern. They said use that idea. So we follow sin 2 theta. You know what is sin 2 theta? 2 sin theta cos theta. 2 sin theta cos theta. But here we need the 1 theta part, not the 2 theta. They say that idea, that double angle knowledge. See what is sin theta? What is sin theta? 2 sin what? Theta by 2 cos theta by 2, is it? Nice question, super problem. Another good idea, this important. So the problem completely costs no sign. Therefore, further you can extend this series pattern. Sin theta equal 2. What is sine theta by 2? Again change to double angle. Sine theta by 2 is 2 sine theta by 2. Next what? Theta by 4. Theta by 4 cos theta by 4 into cos theta by 2. Okay, this. Okay, check that. So otherwise, see, can I say 2 to 2 square? 2 square sine theta by 4 cos theta by 4 at last cos theta by 2. I can show another one also. Right, the other step, other pattern also, then only you can recognize what happened, this idea of series. Again, sine theta 2 to the power, it becomes 3 because what is sine theta by 4? 2 sine theta by 8 cos theta by 8. So the 2 I say 2 power 3. Okay, this is what? Sine theta by 8 cos theta by 8. Okay, others the same, cos theta by 4 into cos theta by 2. So again, still not your problem. I can show another one also. Again, say therefore sine theta equal to what? Next one ever extend this double angle. 2 to the power 4 sine what is that? Theta by 16. Okay, cos theta by 16 are the same. I think that's enough. Therefore, now try another general pattern. Therefore, think a general pattern. First occasion here 2 to the power 1, here 2 2. Second occasion 2 to the power 2, 2 square. The same power comes here 4. 2 to the power 3, that power comes here 8. Same, at last cos theta by 2, at last everything cos theta by 2. Therefore, can you write the same question for the power n? See, we need the up to the power n, up to the power n. So what happened if we start from here? Therefore, now I can write this form. Can I write this form? Oh, write the power n also. Therefore, another pattern, sine theta is, right, therefore generally, write that, therefore generally 2 to the power n, what happened? Sine theta over 2 to the power n, cos theta over 2 to the power n. But the other one, cos theta over 2 to the power, the other, here 2 power is 2, 4, 8, 16 like that. Continue to n minus 1. Is it n minus 1? Less 1. And last you can say become cos theta by 2 is n minus 1. See, this pattern goes like that. It becomes n minus 1 finally. N minus 1, n minus 2 like that. Now the idea, see, check cos theta by 2, by 4, by 8. Everything I can substitute what? Sine theta and these things like that side, is it? Nice question, super problem. So limit n tends to in, now come to this, therefore, what is this? From back here, cos theta by 2, cos theta by 4, cos theta by 8, and up to that, up to this one, is it? Up to this one, right? Up to this one you can write, subject that. Sine theta over 2 to the power n sine theta over 2 to the power n. Okay, it's the part angle is this, right? Now I want to show this one, sine theta over theta. So remember, this is not in terms of theta limit. Limit is n tends to infinity. Therefore, you know the sine relation, sine theta over theta. Then only we have the answer for there. But in this case, how? Here the n part. N part is here. See, n part is here. Here no matter. Is this no matter sine theta? You can't use a limit here because In terms of n is the approach paths tends to that. Therefore, sine theta act as a constant. See, the answer sine theta available. Okay, that's the case here. Okay, so I can show a simple method hereafter. Can I take let theta over 2 to the power n as beta like this? Not necessary, but if I show that it was something easy to understand, right? So I say beta. If you use a substitute wherever integration, differentiation or limits, you have to change all the problem now in terms of beta. First limit is what? Therefore, if n tends to infinity, what is beta tends to? What is beta tends to? 2 theta over 2 to the power infinity, that's 0. Study that. Theta over 2 to the power infinity is a value that is 0. Completely tends to 0, right? When n tends to infinity, what I mentioned, beta is 0, tends to 0. Okay, therefore go to the answer. Therefore, limit n tends to infinity or otherwise beta tends to 0. Okay. And there's no in sine theta, keep as it is, sine theta separate it, okay, separate it, and over, what is 2 to the power n, what is 2 to the power n, check that, theta over beta, 2 to the power n is theta over beta, is it? See, 2 to the power n is theta, but over beta, check that, what is this, sine beta, sine beta. Or if you're confused, I can rewrite that one. That is limit beta approach to 0. Here theta no matter. Theta is a constant number. In this case I write separate. I show separately. Okay. And 1 over sine beta over beta. That is important. So what is the answer? Sine theta over theta. You know, basic. So now another video series I am showing many questions now in the limit, revisions on limit. Sine theta over theta, sine beta over beta, when beta 0, answer is 1. We have the answer sine theta over theta. So I hope you understood this. Important question, similar question can be asked in the future papers also. So practice this. Using this, you think some any other idea of a series pattern.